Hello and welcome back. There was a small video from another class that I assigned for you to watch over variation and inverse variation, but I'm going to do some problems from our book as well. And so if you could turn to our book around page 284, I would like to start with question number 9. So problem number 9 says, Z varies jointly with x and the square of y. So varies jointly with x and the square of y. So varies jointly means we are using the setup of y equals k times 10x. This is a direct variation. And inverse is y equals it. X is an inverse variation with y. So that would be our k, which is k is our constant of proportionality. But on number 9, it says it's a joint variation. So there's two variables that are changing. And so in number 9, the joint variation is z varies jointly with x. So there's some k of proportionality with x and the square of y. So y squared. So 9 says if z is 54, when x and y are both 3, so x is 3 and y is 3, we're just replacing those values. First, we have to find the k, the constant of proportionality that makes this true. So 54 equals k, that becomes 3 times 3 squared is 9. So this becomes k times 27. And when we divide both sides by 27, we get our constant of proportionality k is equal to 2. So we know that z is equal to 2 times xy squared, because we know that k is 2. And then it says, find z when x is 2, so x is also 2, and y is 4. So z will equal 2 times 2 is 4, times 4 squared is 16, so z will equal 64. So the key is to, when it's jointly, that means there's going to be two variables, and then you have to always make sure you incorporate the constant of variation, k. So let's look at 12. 12 says that I varies inversely. So inversely means it's going to be this basic setup up here where the constant of proportionality is on top and your input variables on bottom in the denominator. Inversely with the cube, so we have our constant of proportionality k over the cube of w. And then it says if I is 1/25, so this is 1 over 25, when w is 5, first we have to do that, then we can give it a new situation. So first we have to find k. So 1 over 25 equals k over 5 cubed is 1/25. Okay, so to find k, we need to multiply both sides by 125. So k equals 125 divided by 25. So k equals 5. So our basic equation is really I equals 5 over w cubed. Then the new scenario says, then find I when w equals 10. So I equals 5 over 10 cubed. equals 5/1000 or 5 thousandths. Okay. So this was a joint direct variation on number 9, and 12 is an inverse variation. This is inverse. So let's go over your steps. Is you would create basic equation okay, and then your second thing is substitute values in and solve for K. So you're going to create your basic equation. It's either going to be the direct variation, oops, y equals K times X, or it's going to be the inverse variation, something like this. This is direct. This is inverse. You're going to substitute your values in and solve for K. Then rewrite original equation with K's actual value once you find it. Then you're going to solve for the new scenario. So let's look at a story problem. Actually, let's look. I had a couple other ones I wanted to look at, 13 and 17. So 13 says, Z varies jointly with y in the square of x. So Z varies jointly. So this is my first step. Varies jointly means I'm going to have K times y in the square of x. Okay. Then I'm going to solve for K by substituting in my values. This is my first step. So my second step is I'm going to substitute in my values for Z, and y is 2 and x is 3. And now we're going to, I said, then solve for K. Then here I said, then solve for K. So we're going to solve for K. So this is finishing up step 2. So 72 equals K times 2 times 9. And that will be 18 times K. And then dividing both sides by 18, because we're solving for K, is going to be 4. And then the third step is rewriting your equation with K in it. So it's Z equals 4yx squared. Or you could put the x before the y, x squared y. And then our fourth step is, it says find Z when x equals 5 and y equals 3. So Z when x equals 5 and y equals 3. So Z equals 4 times 3 is 12, and 5 squared is 25. And then we're going to go ahead and put 12 times 25, and we get 300. So it's getting that first couple steps down. So number 17 says, F varies directly with M. So F varies directly with M. So that's Km, because your constant variation is always in the numerator. It varies directly with M and inversely with the square of D. So and D squared is in the denominator because it's inversely with the square of D. So that's step one. So let's look at step two by solving for K. So it says if F is 150, when M is 250 and D is 8. Okay, so let's solve for this. So this is K, 250 divided by 64. So let's do 250 divided by 64. So we get 150 equals 3.90625 K. Oh, this should have been 240. 240 divided by 64. And this type that 151. So this is 3.75. Okay, so now when we divide both sides by 3.75, we get 40. K equals 40. So I'm going to rewrite my original equation. F equals 40m over D squared. And step 4 says, let's look at our new scenario. It says, find F when M equals 360 and D is 3, so that's 3 squared. So F equals 360 times 40, 14,400 divided by 9. Comes out to be F is 1,600. I'll show you my picture. Okay. Let's go up. I would like to do a couple story problems because they're the real life ones that you really want to get any practice with. So 33 is one that I'd like to look at. Let's read through it first. It says, period of a pendulum. A pendulum is something that swings back and forth. So it says, the time it takes for a pendulum to complete one period varies directly with the square root of the length of the pendulum. A 100-centimeter pendulum takes 2.1 seconds to complete one period. So the time, I'm going to say time is T. So I'm going to say time is T. And it says the time it takes for the pendulum to complete one period varies directly. So it's going to be varying directly with the square root of the length. And I'm going to use L for length. So it varies directly with the square root of length. So it says, find the equation. So first we're going to find the equation by substituting in 100 and 2.1 seconds. And then it's asking us to graph this. How long does it take to complete one period if the pendulum hangs 230 centimeters? And let's just make sure our original 100 is in centimeters, so we don't have to worry about any unit exchange. So we have, this is our basic equation. T equals K times the square root of L. And we know that the time we said was 2.3 seconds when the length is 100. Okay. So square root of 100 is 10. If we divide both sides by 10, we get 0.23 is K. So T is really equal to 0.23 times the square root of L. So that's A. B is graphing. We can do that in Desmos. C says, how long does it able to complete one period if the pendulum hangs 225 centimeters? So the time when L is 225. So the square root of 225. So don't forget the square root of 225 there is 15. And we're going to multiply that by 0.23, and it looks like it's going to take 3.45 seconds. And we could look at this one and that's not for fun here. And we could put in, instead of t, we're going to use y equals 0.223. And then we have to get our square root in the menu here. And it's down here at the bottom. There it is. And inside that square root, we're going to put x so that we can see. And this is the graph here. And then a little bit here. So it goes and it goes gradually up to forever. Yeah, very good. So how about we look at one more story problem for fun? How about 25? Let me take you back to my. So 25 says volume and pressure. The volume of a gas is inversely proportional to the pressure, inversely. So the volume, I'm going to say is V, is inversely proportional. So our constant of variation is going to go on top. Inversely means the pressure P is going to go in the denominator. So that's going to be our basic setup. V equals K over P. V equals K over P. So you have to know if it's direct variation or inverse. That's the key. Okay. If the pressure is 36 pounds per square inch corresponds to a volume of 25. So the volume is 25 when the pressure is 36. Okay. So we need to solve for K. So we're going to solve for K, we're going to have to multiply both sides by that denominator. We learned that back in chapter 2. So K is 900. So our equation is really this. And it says what pressure is needed to produce. So the pressure is what we're looking at here. We're trying to solve for the pressure. To produce a volume of 75 square cubic feet. Okay. So this is a good one. So to solve for pressure, we need to get pressure in the numerator. So we're going to have to multiply both sides by P for the pressure. So I get 75P equals 900. So then to solve for pressure, we're going to have to divide by 75. So 900 divided by 75 is 12. So it looks like the pressure is going to be pounds per square inch. Oh, we have units too. Make sure you're using pounds as LB. So hopefully those get you going on 3.7. Catch me back for the next lesson.